Okay, and if we remember what our C matrix is, we can just immediately go and replace that, and we get that same definition. So the point being, if I can get a transfer function, any transfer function, into that form, then I can immediately go to this state space representation without any problem. Okay? That make a little bit of sense? Okay, so as an example, okay, so I have some transfer matrix, all right? It's a 2 input, 2 output system. I know that because the matrix is 2 by 2. And what I need to do is get it into a form where I have a matrix in the numerator and a polynomial in the denominator. Okay? So, and recall that I also want to have a strictly proper matrix plus that instantaneous response. So the first thing I want to do is find where my matrix, where's my matrix not strictly proper? Where's the order of the denominator not greater than the order of the numerator? And it's in the upper left-hand corner, right? So, first things first, I have to make that into a proper matrix, okay? I think that's equal to if I multiply this by 2s plus 1 over 2s plus 1, I get 4s plus 2 minus 12. Sure looked right. That's good. This is minus 10. Let's try that again. That seems to look a little bit better. Okay, so I can rewrite my transfer matrix and rewrite it like that. Now I've got my instantaneous response, and I've got my strictly proper transformations. Take the instantaneous response, we will ignore it for the time being, because it just shows up in the end. It's just the D matrix of the state space representation, right? So just by making this strictly proper, we found our D matrix. Now we need to find the rest. So the next thing that we have to do is we need to find a common denominator, right? We need a polynomial in the denominator of this matrix. So I got a 2s plus 1, I got an s plus 2, and s plus 2 squared. Looks like we can probably do that. So I'm just going to make that common denominator, and then we can factor it. Right, so now we've got our A matrix figured out already. Right, because all my alphas are just the constants in my polynomial. Okay, so now we've already figured out A. Okay, so now what I did is I just put down my common denominator, and then this guy has that, but twice of it, and it needs an s plus 2 squared, so I just did that, took off the half. This guy needed a s plus 0.5, so I gave 1 and an s plus 2. This guy doesn't, it needs an s plus 2, and that guy needs an s plus 0.5. Okay, so everything stays the same, right? So then I can go ahead and then create polynomials out of all of these by factoring, right? And if I create polynomials out of all of those, I can group them into individual matrices. Okay, so now I've got my numerator in the form that I need it in, right? Just like this. So now I've got matrix C, right there. I've always had matrix B because it's just 1 plus a bunch of zeros. So just by monkeying with this matrix, getting it strictly proper plus a constant, and creating a common denominator, I can immediately say that the state space, or a state space representation of this, is each of these constants on my polynomial, they're all going to be negative. And then P, that's the number of inputs. P inputs, Q outputs. And then we get the identity matrix here. And then I'm looking for my C matrix, which is just each of the constants in front of my polynomials. That's here, so I got -6 and 3, 0 and 1. And then lastly, I have my D matrix, and I had my D matrix all the way back when we were trying to make this thing strictly proper. That's my instantaneous response, if you will, or it's just a D matrix. Does that all make some kind of a semblance of sense? If I've given my transfer matrix, there's not a lot of work to be done. It seems like a lot of writing, but all I need to do is make it strictly proper, find a common denominator, and boom, I got a state space representation, which is nice and diagonalized for me. And it makes things even easier if I only have a single input system. If I have a single input system, then all those identity matrices just become scalars. I think Dr. Ratliff is showing his age by playing 1990s Weezer music in this class. Okay, so this is for single input. I just want to make a point that we had a 2 input, 2 output system. Since we had 2 inputs, each of these things had to be multiplied by an identity matrix that was 2 by 2. Okay? If we go to a single input system, then it becomes even simpler. It's just your polynomial scalars on the top, diagonal, and then a 1, a bunch of zeros. All right, so that was all of chapter 4. So chapter 4 homework is on Isidore. Take a look at it. Let me know. Remember that Tuesday is the only time we are meeting next week. So if you have questions, ask them on Tuesday.
On the homework, for number 4, it says, are the 2 sets of state equations like blank and blank? Or did you mean to say equivalent, I'm assuming? It doesn't say anything after that.
That's exactly what I meant. Let me see. Homework. F4. You said problem 4?
Yeah.
Yeah, I don't know where that went. I would say, are these 2 set of state equations, I think we call it 0 state equivalent. I think. I can't remember the exact term that we used. Don't know anymore. Give me 1 second. I want to be. So we did our equivalence transform. No. Yeah, I guess for lack of a better term, that are those 2 sets of state equations equivalent? I will go ahead and look and see what I did to screw that up and try to update it. But and you can see that problem 5 is just exactly like the example we did up on the board, and that's the only one that you need to do by hand because I don't know how to use MATLAB to do that. Cool. All right, I will see you all on Tuesday. Yes. Yes. So, you wanted to sit down and talk, and I haven't responded to you yet. Okay, I will,
I want to make an appointment, you said.
Yes. Yes, I know, I'm sorry. I will, tonight I will dig through my email, and I will find your email, and I will respond to you at a time.
Because only on days of my classes.
Okay, only Tuesdays and Thursdays? Okay. Okay, and like, I assume you'd want it later in the day, 8 AM is not really gonna work for you?
If you say I will.
No, I'm not going to do that. So I'll try to make it sometime, like after 10, if that's,
Yeah.
Okay.
Thank you.
all right. I promise you, I will look at that tonight, and I will respond to you tonight.
Thank you so much.
All right.
Have a good day.